Hello dear viewers, welcome to TV Math. This is your home for clear and practical mathematics. For those that are here for the first time, you are highly welcome, and please consider subscribing to this channel. Subscribing is completely free of charge. In our today's session, we want to look at one more question about linear algebra revision questions and answers. We have so far discussed many questions pertaining linear algebra, and please kindly consider revisiting some of these videos to understand more about some different concepts in linear algebra. So let us look at this question without wasting time. So the question says, let u be equal to this and v be equal to this. Compute u plus v. Okay, so let us look at the solution. How do you compute u plus v? U plus v, we have got our u, which is same as 2, -1, and 3. So this is same as 2, -1, and 3. So you are adding there -1, 4, and 2. You can do the addition using this, or else you can put this in what we call the column form. So if you put this in column form, u plus v will be same as 2, -1, and 3. Then adding there -1, 4, and 2. So in other words, when you are adding vectors, you add component wise. So let us add the corresponding entries. 2 with -1, 2 plus -1, -1 plus 4, then 3 plus 2. So this will give us, this will be able to give us 2 minus 1, that is 1. This will be 3, and this will be 5. So we shall get 1, 3, and 5. So otherwise you can also maintain it in this way. So you will add here 2 with -1, you will add -1 with a 4, you will add a 3 with a 2, and this still will give you 1, will give you 3, will give you 5 as your answer for u plus v. And when you get this as your u plus v, make sure you return it back in the original form, which is a coordinate form. So it means your u plus v should be written as 1, 3, and 5, and this will be the required answer. So next we want to look at 3u. So what will be 3u? 3u is same as having 3 into u, which is 2, -1, and 3. So this is same as having 3 multiplied into that, 3 times 2, 3 times -1, and 3 times 3. So this should be able to give us 6, -3, and 9, and this will be the answer. If you do it in column form, then you will have 3u, which is same as 3 into 2, -1, and 3, which will give us still 3 times 2, 6, -3, and 9. But having this, then you must conclude that therefore your 3u is 6, -3, and 9. So that is how we obtain the answer. Okay, so we have looked at u, then 3u. So next let us look at that. So next we shall look at 2u minus 3v. So this will be 2 into u is 2, -1, and 3. Then we are subtracting 3 into -1, 4, and 2. So let us first multiply 2 inside here. We shall get a 4, -2, and 6. Then minus, first maintain the negative out, then multiply 3 here, -3. This is 12, and this is 6. So we shall have this as 4 minus 3. 4 minus 3. Let us have it here. 4 minus 3. -2 minus 12. 6 minus 6. So this should be able to give us 7 minus 14 and 0. So basically we shall have our answer for 2u minus 3v as 7, -14, and 0. So this will be the required answer for part 3. So far this is done, and this is done. So I hope this is very easy to compute. I hope this is very easy to compute, and for that case you should now be able to compute this part. You are given a, b, and c. You need to compute a plus b plus c. You need to compute 4a minus 2b plus c. So you should be able to compute for these vectors as well. So let us look at another question.
So I'm assuming that you will be in position to compute this. Please compute that and put your answers in the comment section. Get a plus b plus c, get the value. So you are getting 1 2 plus 3 1 plus 2 3. You are adding the corresponding entries. You are having 4 into 1 2 minus 2 into 3 1, then plus 2 3. You can use this format, or else you can put them in the column form as we have seen above. So this you should be able to try it out. So let us look at another question. Another question says, let x be equal to that and y be equal to that. Verify the scalar multiplication. Verify that scalar multiplication satisfies distributive law, and you need to confirm whether this is true, whether the left hand side is equal to the right hand side, provided k is equal to 2. So here you are given the value of k, you are given the value of k, you are given the value of x and y. So what you do here, you consider one side at a go. Let us first consider the left hand side, which is k into x plus y. So what is k? K is 2. Then we are having this into x, which is 1 negative 2, plus y, which is 3 and 5. So that is what we shall have. This is 2 into, this is now add 1 plus 3, that is 4, negative 2 plus 5, that is positive 3. So multiply 2 is 4 to give us 8, multiply 2 is this to give us 6. So it means our k into x plus y is same as 8 and 6. Same as 8 and 6. Then next you will talk about kx. You will talk about kx. K is 2 into x, 1 negative 2, and this will give us 2 times 1, 2, 2 times negative 2, negative 4. This is kx. Then what is ky? Is 2 into 3, 5. This is same as 6. This is same as 10. So we also look at kx plus ky, and this is the right hand side. So the right hand side will be 2 negative 4. You are adding there 6 and 10. So this will give us 2 plus 6 is 8. Then negative 4 plus 10 is 6. So this kx plus ky will be same as 8 and 6. Will be same as 8 and 6. So this will be the answer for that case. But we have got kx plus ky, we have got this. So we need to give a conclusion whether the two are the same. So from these two, then we should be able to see that both sides, therefore both sides, because we can easily see the left hand side is equal to the right hand side. So both sides are equal. So both sides are equal. So therefore, so the distributive law holds. The distributive law holds. The distributive law holds, since the left hand side is equal to the right hand side. So that will be proved. So let us look at the next part. Let u be equal to that and v be equal to that. That is basically same as what we did. Okay, so we have already done that. This one is done. Then this part 3 is also done so far. Let us now look at part 4. Let us look at part 4. Okay, so all that is computed. So you should be able to compute these as well. So these are some of the different questions you need to try out. So let u be equal to that, v equal to that, compute this, this and that. You should be able to try that out. A is this, b is that, c is that, compute this. You should be able to try that. Then let x be equal to that, y be, verify the scalar multiplication for k equaling to this. You should be able to try it out. So we want to look at the next, which is 4, where they say express this polynomial as a linear combination of the polynomials p1, p2, and p3. So basically, in our previous video, we talked about linear combination. So we are dealing with vectors from R3. We are dealing with vectors from R3. So here we are dealing with vectors from a polynomial space. So let us look at how best we can express this as a linear combination of that. It will be almost the similar way that we did in our previous cases. So we shall now be able to do this with ease. since we have already talked about some of these numbers here. That is about linear combination, we talked about linear independence, we talked about the definition of a vector space. So we looked at all that. So basically, let us see how best we can also answer this question. So the question is, we need to express p, which is 3 t squared plus 5t minus 5 as a linear combination, of the polynomials p1, p2 and p3. So p1 is t squared plus 2t plus 1. Then p2 is 2t squared plus 5t plus 4. Then p3 is same as t squared plus 3t plus 6. It is same as that. So that is what basically we are having. p1 is that, p2 is that, then p3 is that. And this is our p. This is our p, which we need to express as a linear combination of this. So like the way we did in our previous cases when we are dealing with R3, we shall do the same. So what we need is, we seek for the scalars. Alpha 1, alpha 2 and alpha 3, such that this alpha 1 times p1 plus alpha 2 times p2 plus alpha 3 times p3 will be equal to p. Okay, so our interest is to get alpha 1, alpha 2 and alpha 3. So this is alpha 1 into p1 t squared plus 2t plus 1, then plus alpha 2 into 2t squared plus 5t, then plus 4. And then again we add there alpha 3 into t squared plus 3t, then plus 6. This should be equal to 3t squared plus 5t minus 5. So from there, what we need to do is, we need to get the coefficients of t squared, then we get the coefficients of t, then we get the coefficients of the constants. So what we do is, we multiply this one here, but I want to multiply and equate at once. So let us combine the coefficients of t squared. Here t squared has got alpha 1 plus, here the t squared, the coefficient will be alpha 2 times 2, that is 2 alpha 2. Then here the coefficient of t squared will be alpha 3. So all these are into t squared. Then the coefficients for t, here it will be 2 alpha 1, here it will be 5 alpha 2, and here it will be 3 alpha 3. These are into t. Then the constants, this will be alpha 1. Here we shall multiply this one with this to get 4 alpha 2. Then next we multiply this one with 6 to get 6 alpha 3. All these, remember, are equal to 3 t squared plus 5t minus 5. That is what basically we shall have. So from here, if we want, you can first multiply alpha 1 throughout, you multiply alpha 2 throughout, you multiply alpha 3 throughout, then you come to this stage where you combine the coefficients for t squared, coefficients for t, coefficients for the constants, or the constant coefficients. So basically, that is what we shall have. Then from this given point, we shall have to equate the coefficients of t squared with the coefficients of t squared this side, coefficient of t with the coefficient of t this side, then constants with the constant term this side. So next we equate the coefficients for t squared. So the coefficients for t squared, we shall have alpha 1 plus this plus alpha 3 to give us 3. So this will be alpha 1 plus 2 alpha 2 plus alpha 3 to give us 3. These are the coefficients of t squared. So these are t squared coefficients. Okay, so next we equate the coefficient for t. 2 alpha 1 5 3 equaling to 5. So we shall have 2 alpha 1 5 alpha 2, 3 alpha 3 is equal to 5. These are coefficients for t. And then we shall have the constants alpha 1, 4, then 6. So 1, 4, 6. So we shall have alpha 1, 4 alpha 2, then 6 alpha 3 to be equal to, so this side the constant is negative 5. So next is negative 5. So these are the constants. Then from here, our interest as usual is to obtain alpha 1, alpha 2, and alpha 3. So you know the procedure of doing that. So let us consider equation 1 and 2. Then we eliminate maybe alpha 1. So we have alpha 1 plus 2. Okay, let us do it at once. We need the coefficients to be the same. Let us multiply 2 in this. Then we consider it with alpha 2. So this will be 2. This will be 4 alpha 2. This will be 2 alpha 3, which is equal to 6. We consider it with 2 alpha 1, 5 alpha 2, 3 alpha 3, which is equal to 5. So from here, let us subtract. So when we do that, this will be negative alpha 2, this will be negative alpha 3, which is equal to 1. So I can multiply through by negative, and I have alpha 2 plus alpha 3 is equal to negative 1. This will be equation number 4. Okay, so we have equation number 4. So from there, let us also consider this and this. So the coefficients are the same, so that is already okay. 1 and 3. So we have alpha 1 plus 2 alpha 2 plus alpha 3, which is equal to 3. We have alpha 1 plus 4 alpha 2 plus 6 alpha 3, which is equal to negative 5. So we shall simply subtract. This will give us minus 2 alpha 2. This is minus 5 alpha 3. This is equal to 3 minus 5, that is 8. So we multiply through, that will be 2 alpha 2 plus 5 alpha 3, which is equal to negative 8. So equation number 5. So we have got these are two equations. What we can do now is to consider equation 4 and equation number 5. So when we do that, we shall have this is 2 alpha. So I want to eliminate this. Let me multiply 2 in equation 4. I multiply 2 in equation 4, then I consider it with equation 5. So 2 equation 4. When I multiply 2 in equation 4, I will have 2 alpha 2 plus 2 alpha 3, which is equal to negative 2. Here I have 2 alpha 2 plus 5 alpha 3, which is equal to negative 8. So I will again subtract. This will give us negative 3 alpha 3, which is equal to negative 2 minus that is the positive 6. So meaning alpha 3 is negative 2. So alpha 3 is negative 2. So having got alpha 3, we can go on and get alpha 2. Let us use equation 4. So from 4 we have alpha 1 plus alpha 2, which is equal to negative 1. Let's check here. Alpha 2 plus alpha 3, negative 1. This is alpha 2 plus alpha 3 is equal to negative 1. So alpha 2 plus negative 2 is equal to negative 1. So alpha 2 is equal to negative 1 plus 2, which is positive 1. So alpha 2 is positive 1. Okay, so let us see how best we can now get alpha 1. We can use equation 1. So let us use equation 1. So from equation 1 was alpha 1 plus 2 alpha 2 plus alpha 3, which is equal to 3. So we have got alpha 1, we have got alpha 2 and alpha 3, so we can easily get alpha 1. So 2 into 1 plus this is negative 2, so which is equal to 3. This is alpha 1, this will give us 0, so alpha 1 is equal to 3. So clearly we have got the values for alpha 1, alpha 2 and alpha 3. So let us now write P as a linear combination of P1, P2, and P3. So therefore, we shall have thus we shall have P as alpha 1 is 3, P1, then plus alpha 2 is 1 into P2, then plus alpha 3 is negative 2 into P3. So therefore it means P is same as 3P1 plus P2 minus 2P3. So from here you will have expressed P as a linear combination of P1, P2, and P3, and that will be the required answer. So it means our part 4 will also be answered, and lastly we look at part 5, which says let V be a vector space of a 2 by 2 matrices over R. Determine whether the matrices A, B, and C are linearly dependent or independent, where we are given this. So for linear independence, to determine a linear independence, what we do, so we can say to determine linear independence, what we shall do is to solve, or to get the linear combination of this one, we equate it to 0. So it is to solve, for example, x of A plus y of B plus z of C. We equate this to a 0 matrix. So where these are our scalars x, y, and z. So you seek to obtain the scalars x, y, and z for which the linear combination is equal to 0. Okay, so let us obtain these scalars x, y, and z. Okay, so we have x into A is 1, 1, 1, 1, plus y into 1, 0, 0, 1, plus z into 1, 0, 1, 0. This should be equal to a 0 vector. This is a 2 by 2, so a 0 vector will be also a 2 by 2. So you can multiply this one inside here. This is x, 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 plus y, 0, 0, y, then plus z, z, 0, 0. This should be equal to 0, 0, 0, 0. So from here, let us add the corresponding entries. So we shall have x plus y, this with this with this, plus z. This with this is 0, plus that is x plus z. This plus this plus this is x. This plus this is x plus y, plus 0 is x plus y. So this will be equal to 0, 0, 0, 0. So from here, obtain 4 equations. X plus y plus z is equal to 0. Equate each of these to 0 because this and this are equal. So equate the corresponding entries to 0. X plus z is equal to 0. X is equal to 0. X plus y is equal to 0. So 1, 2, 3, and 4. So from there, obtain the values for x, y, and z. So x is 0. So we can say from 2, x plus z is equal to 0, meaning 0 plus z is equal to 0, giving us z as 0. So next we can use from 4, x plus y is equal to 0. So 0 plus y is 0, so y is equal to 0. So this should be able to satisfy equation 1. So 0, 0, 0 will be equal to 0. So that will also be satisfied. So generally we can see that the only solution is x, which is equal to y, which is equal to z, which is equal to 0. So what does that one mean? If you find all the scalars are equal to 0, so it means A, B, and C are linearly independent. So for linear independence, all the scalars must be equal to 0. But if we find one of them is not equal to 0, then we say they are linearly dependent. And for this case, since all of them are equal to 0, we shall have this as a linearly independent. And basically, that would be at the end of our session. So if you find this video helpful, don't forget to like, share, and most importantly, to subscribe to this channel. Thank you. We meet in our next session.